students, this is real numbers third topic. We already completed first equilibrium division lemma and fundamental theorem of arithmetic. What is equilibrium division lemma? Once we have to remember, given a comma b are any two positive integers, then there exists a unique pair of integers q and r satisfying a equal to bq plus r, 0 less than or equal to r less than b is the equilibrium division lemma. By using this equilibrium division lemma, we are finding HCF and also odd numbers, square and cubing number forms. Now second one, how to find the LCM and HCF by the prime factorization method. We also completed that one. And fundamental theorem of arithmetics. What is the fundamental theorem of arithmetics? Every composite number can be expressed as a product of powers of primes and its factorization is unique. Every composite number can be expressed as a product of powers of primes and its factorization is unique. Now we are going every rational number either terminating or non-terminating repeating or non-terminating non-repeating decimals. That means three types of numbers. If you are writing terminating, three types, what is that? First one is terminating and the second one is terminating repeating. Terminating repeating. These two are called the rational numbers. Terminating decimals are called the rational numbers. Non-terminating repeating decimals also rational numbers. But the third case, non-terminating, non-repeating or non-repeating decimals are called the irrational numbers. Non-terminating, non-repeating decimals are called the irrational numbers. Now we are going to the terminating and non-terminating repeating decimals. We have three theorems. First theorem 1.3, theorem number 1.3. Once see the page number 19, 1.3 theorem statement. Once go here. Let x be a rational number. Let x be a rational number. X means rational means it is in the form of p by q. X is a rational means p by q. Whose decimal expansion terminates. Whose decimal expansion is terminates. For example, I am taking 1 by 2. It is 1 divided with the 2. It is not possible 0. Now it is 10. 5 times 10 it is 0. That means 0.5. It is terminates. If let x be a rational number whose decimal expansion is terminates, then x can be expressed. If the decimal is terminates, then x can be expressed in the form of p by q. Then only we can write in the form of p by q. And where p comma q are co-primes, and the prime factorization of q, what is q? It is the denominator. The prime factorization of q is of the form 2 power n into 5 power m. If you take here it is 2 can be written as 2 power 1 into 5 power 0. That means it is of the form 2 power n into 5 power m. Then by this 1 by 2 is a terminates. Once I will explain again. Let x be a rational number. If it is a rational number whose decimal expansion terminates. If it is a rational number and also decimal expansion is terminates, then x can be expressed. Then x can be expressed in the form of p by q, and where p comma q are co-primes, and the prime factorization of the denominator q, the prime factorization of the denominator q is of the form 2 power n into 5 power m. Now I am taking one more example. 25 by 2 is a rational number. Now 25 by 2 can be divided with 2. 12 2s are 24, then the remainder is 1. Decimal it is 10, 5 times now the decimal is 12.5. This decimal form is 12.5. Terminates. If it is terminates, write in the P by Q, and Q must be in the form of 2 power n into 5 power m. What is the Q here? 2. 2. How to write? Already we write here 2 power 1 into 5 power 0. Then it is in the form of 2 power n into 5 power m. This is the theorem number 1.3. Now we are going to page number 11, 1.4 theorem. Page number 11, 1.4. Once see here. Let x is equal to p by q be a rational number. Let x be a p by q be a rational number such that the prime factorization of q is of the form 2 power n into 5 power m. The prime factorization of q means denominator is of the form 2 power n into 5 power m, where n and m are non-negative integers. Where n and m are non-negative integers. That means either positive or 0. Non-negative means either 0 or positive numbers. Then x has a decimal expansion which terminates. Then x has a decimal expansion which terminates. 1.4 theorem is the converse of the 1.3 theorem. What is saying here? Let x is equal to p by q be a rational number such that the prime factorization of q is of the form. If the q form is in this form, where n comma m are non-negative integers, then x has a decimal expansion which terminates. That means q అనేది ఈ ఫామ్ లో ఉంది అంటే కంపల్సరీ which is terminates. That number is terminates. Now we are going to the page number 12. In the page number 12 we are going to 1.5 theorem. Once go through 1.5 theorem. Let x is equal to p by q. Let x is equal to p by q be a rational number such that prime factorization of q is not of the form 2 power n into 5 power m, where n comma m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating. Once observe again. Let x is equal to p by q be a rational number such that the prime factorization of q is not of the form. Before 1.4 and 1.3 it is of the form 2 power n into 5 power n. But now this case q is not of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating decimal. Now I am taking one example, that is 1 by 3. I am taking an example 1 by 3. Now 1 will divide with 3. It is not possible, then we can take decimal. 3 3s are 9. Again we got 1. Again it is decimal, that means 10. 3 3s are 9. Again it is continuous. It is also continuous. Once observe here, 1 by 3 is of the form p by q, is a rational number such that prime factorization is not of the form. Once observe here 3. 3 cannot be written in the form of 2 power n into 5 power m. How to write this is, just you have to write 3 power 1 into either 5 power 0 or 2 power 0. Just you have to write 2 power m into 5 power n, but not other numbers. Then if like these numbers are called non-terminating repeating numbers. Yes, by using these three theorems 1.3, 1.4 and 1.5, you have to complete exercise 1.3. Once go through the 1.3 exercise, page number 12, first Roman, write the following rational numbers in their decimal form and also state which are terminating and which have non-terminating repeating decimal. Now I am taking the first problem, 3 by 8. Just you have to say it is terminating or non-terminating. Now I am observing just q. It is 8. 8 can be written 2 cube, means 2 cube into 5 power 0. It is in the form of 2 power n into 5 power m. 2 power n into 5 power m. Now the number 3 by 8 is a terminating decimal or rational number. 3 by 8 is a terminating. How to say it is? It is in the form of 2 power n into 5 power m. The denominator is in the form of 2 power n into 5 power m by the theorem 1.4. Now we are going one more example. 224, second one. 229 by 400. 229 by 400. Just you have to take the denominator is 400. If any cancellation, first I have to cancel, but it is a prime number. Now I am taking just 400. 400 can be written prime factors. 2 table 200 times, again 2 table 100 times, again 2 table 50 times, again 2 table 25 times, 5 table 5 times. Then I am writing 2 power 1, 2, 3, 4 into 5 square. Now it is in the form of 2 power n into 5 power m. Therefore 229 by 400 is also terminating decimal. Like this you have to complete the first Roman. Now we are going to the second Roman. Without performing the division, now also I am not complete the division. You have to complete by division also in first Roman. But in second Roman, without doing division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal. 13 by 3125. Second Roman, first one. 13 by 3125. Now I am doing without division. 13 by 3125 can be written in the prime factorization method. 5 table, 5 6 are 30, 2 5s are 10, 5 5s. Again 625 in 625 5 table 125 times. Again 5 table 25 times. Again 5 table 5 times. 1 2 3 4 5. That means 13 by 5 to the power of 5 into 2 power 0. Now the denominator q must be in the form of 2 power n into 5 power m. 2 power n into 5 power m. Then it is also terminating. It is terminating decimal. Like this you have to complete second Roman also. Now I am one more problem. I am taking seventh one. In the same Roman, seventh problem. 129 by 2 power 2, 5 power 7, 7 power 5. Now without doing division, you have to say this is a terminating or non-terminating repeating. Now I am observing the just denominator. What is the denominator? Is of the form 2 power m into 5 power n into some 7 power o also. Not 0, it is some z also. That means it is not of the form 2 power m into 5 power n. Now it is non-terminating. Repeating. Non-terminating repeating decimal. Non-terminating repeating decimal. If any cancellation, first you have to cancel the number. After that you have to write, is it denominator is of the form 2 power m or not. If it is in the form of 2 power m into 5 power n, write terminates. Not in the form of 2 power n into 5 power m, non-terminating repeating decimal. Like this you have to complete the second Roman also. Now we are going to the third Roman. By using theorem 1.2, write the following rational numbers in the decimal form. Decimal form 13 by 25. 13 by 25. Just you have to product. You can change into 10 or 100 or 1000 like this. Now I am writing 13 into 4 by 25 into 4. Why? Because 25 4s are 100. Now it is 100. 13 4s are 52. Just you have to write 0.52. 0.52. 2 zeros in the denominator, just you have to give the decimal before two numbers. 0.52. And 15 by 16. Like that you have to complete remaining 4 problems also. And fourth Roman. First one. What is the fourth Roman? The decimal form of some real numbers are given below. In each case, decide whether the number is rational or not. Is it rational or not? If it is rational, express in the P by Q form. What can you say about the prime factors of Q? Now I am now taking the first number. Fourth Roman, first problem. 43.123456789 can be written is equal to in decimal form. Just write the total number 4 3 1 2 3 4 5 6 7 8 9 by after decimal how many numbers are there? 1 2 3 up to 9 numbers. Then write 9 zeros. 5 6 7 8 9. This is the fractional form. Rational form of 43.123456789. Rational form is 4 3 1 2 3 4 5 6 7 8 9 by 10 to the power of 9. Now this can be written in the form of Q equal to, in this case Q equal to 1 0 0 0 0 5 6 7 8 9 can be factorized 10 to the power of 1 2 3 4 5 6 7 8 9 9. That means 2 into 5 whole to the power of 9. 2 power 9 into 5 power 9. Now Q must be in the form of 2 power m into 5 power n. Now it is a rational number. It is a terminating decimal. Thank you. Like this you have to complete this total exercise.